Tu devrais avoir un écran noir. Yes. Bonjour, good afternoon. Thank you for attending this session on Starter Kits. I'm Xavier Robert. I'm Developer Advocate in France, and I'm today with Georges-Henri Moll, who is also a Developer Advocate in France and a data scientist. So this session is about Starter Kits. So you will see that we have this year three Starter Kits to help you getting started. So we will see the zero anger starter kit, the clean water and sanitation starter kit, and the responsible production and green consumption starter kit. So Georges-Henri with me today has been participating in elaborating, writing the responsible production and green consumption starter kit. Georges-Henri?
Yes, hi, thank you, Xavier, and thank you everybody to be here. And yes, right now we are going to explain what are starter kits. Basically, they are meant to give you ideas, help you start it from a technical point of view, from a semantical point of view. So enjoy the video. Thank you very much.
Okay, so this will be a pre-recorded video that we are going to use today, but will stay available in the chat for questions, and we'll get back to you at the end of this pre-recorded video. Georges-Henri, up to you.
So this is the main page for Call for Code. This is a very simple page, callforcode.org. And right now, I understand that everybody wants to be the next winner of Call for Code because it's really tech for good. There is a big prize, and it's really good for the planet. So how to win? So from what we have heard from Timo, to be the next Timo, you basically need three things. First thing is understand the problem and find a sub-problem that you want to address. Second point is have ideas. And the third point is, apply your technology skills to implement some solution. For the first point, which is understand the problem, there is this button here. This button here is see the challenge details. And for the two other points, which is have ideas and use your technology skills and get deep dive into the needed technologies, we have these starter kits. And I will be talking about starter kits mainly now. So let's still have a look at the challenge details. As mentioned previously, there are three major challenges: clean water and sanitation, zero hunger, responsible production, and grid consumption. To understand them, there is a small description here, but it's a good idea to go to the United Nations website. And here we see that we have all those global issues. And among them, we see food. So we have this hunger problem, we see water, etc., etc. We see sustainable development. And if we dig into those problems, we can actually see that there are 12 goals for the United Nations. And clean water and sanitation is goal number 6, zero hunger is goal number 2, and responsible consumption and production is goal number 12. So let's dig into goal number 12. As mentioned before, this is about responsible consumption and production. And the point is that, well, one major issue that we have is that each year a third of the food production ends in trash and is rotting in the bins of consumers and retailers. So this is the big problem. And there are plenty of other facts and figures that you can see in this page. So I encourage you to go to the United Nations web page and dig those figures to understand how deep those problems are. Then we have targets. So those are goals that have been stated by the United Nations to address those problems. So this is really a source of inspiration for the call for code. And here you can see things very important like encourage companies to adopt sustainable practices, promote public procurement practices that are sustainable, etc., etc. And there are, of course, links which also points you to other resources. So if we dig a little more into this this number 3 theme, which is sustainable production and consumption, we can see here, still on the United Nations website, that 3 major sub-problems have been proposed. One of them is decoupling environmental degradation with economic growth, which is basically doing more and better with less. Another one is life cycle thinking, and the third one is opportunities, sizing opportunities for developing countries. The one that has been chosen in the starter kit. So you get now to the starter kit. It's very simple. From this page that we have seen before, you can click on responsible production and consumption here. And here, what do we have? We have an overview of the problem, reminding you the goals. So let's see, for example, again at goal 12 and description of goal number 12. And in this description, we see, for example, this recycling question, which is put forward. Okay. So this is the angle that has been taken for this starter kit, first starter kit. This starter kit, in each starter kit, you have an overview, you have an ID, an architecture, and a set of resources. So the overview, again, is a reminder of what is the problem. And this is, again, the starter kits are just example, IDs, architectures, but there is absolutely no obligation to follow them. It's just a starting point that you might use if you want to dig into ideas, if you want to dig into technologies, but there is no obligation at all in the call for code to follow them. Still, the idea that has been chosen here to address this recycling problem is to put together the producers and manufacturers and make them cooperate on the platform. So this platform here is implemented in this architecture. So let me dig into this architecture to describe it a little bit more. So the users, again, the users are the producers and also the people who are recycling materials and putting recycled material back on the market. So the users are interacting to the platform through a front end here, which is written in a React app, and the back end is written in Node.js, which is an architectural choice that you might or might not follow, obviously. In order to achieve a scalability, we have put it into a Kubernetes environment. The monitoring is done through the New Relic component. And the originality of this application is that it goes, it uses information on the market data that are open information. So the idea is to be able to get information in the form of documents and use Watson Discovery, which is an NLP component, part of Watson Suite, which allows you to explore those documents and put them into a structured form which is understandable from a computing point of view, and be able to put them back into a database. Here we have chosen the Cloudant as a database. So let's get to allow you achieve this architecture or similar architecture. We have resources. Three types of resources: technology, datasets, and documents. Technology, we have tutorials. Here we have a tutorial, for example, on how to deploy a Kubernetes application or how to perform intelligent search on data. Intelligent search is the Watson component I have mentioned before, which is Watson Discovery here. Resources and services that you can use. And here, for example, this is an IBM Kubernetes service, which is available on IBM Cloud Public. If you follow it, here it is. And most of, not to say all, are available in a freemium version, which allow you to prototype or to develop applications which are demonstratable. And then we have also pointers to Watson Discovery, which is a component that I have mentioned before, and Cloudant. Now the component, the data sets, there are many data sets that are open data sets that you can get. So let's, for example, dig on the European open portal for data here. And on this portal, you can get data which might be useful for your application, for your candidate application for Code for Code. And of course, we have also non-governmental organization documents, in this case about circular economy, recycling, etc. Okay, now let's look at the second theme for Call for Code, and the second theme has also a starter kit. This is the zero anger theme, sub-problem, if you wish. And now let's maybe get back to the United Nations site here. The zero hunger is number 2 goal from the point of view of the United Nations. So as mentioned before, there are almost 700 million people who are hungry. And after decades of decline, and the hunger in the world has been rising again slowly, but unfortunately steadily from 2015. So this is a real big problem today. It has been increased by the COVID problem, obviously. Here we have much more facts and figures again, and targets. Among the core targets, again, you can find ideas to or sub-theme that might be the one that you want to address in your application for Call for Code. And you see, for example, that we have maintaining the diversity, the genetic diversity of seeds, ensure sustainable production and implementation of resilient agricultural practices, etc., etc. So let me get back to the Zero Hunger Starter Kit. The idea that has been pushed forward for this starter kit is to allow people, to allow producers in a cooperative to basically dematerialize the information that they have and share it in order to be, as a collective, more efficient than as individual producers, so that they can cooperate on analyzing market, on sharing transportation, on understanding demand, and many other things like that. And for each starter kit also you have these see more buttons ideas that you might want to use. Okay, the architecture chosen here, let me dig on this architecture. The center point are mobile phone, and they are supposed to be non-smartphone, because in many countries, and especially in countries where hunger is an important problem, there might not be so many smartphones, and the application should work for any kind of smartphone. So the idea is to use the smartphone to push text or images which have been important from sources, to use those smartphones to push information towards the application. So the kernel of the application is written in Node-RED, which is a technology which allows you to do visual development in JavaScript, in Node.js, basically. And this application gets all the information which can be text and images and push them to a machine learning system, which is based also from a point of view of memory to a cloud object storage. Here we have put the main application on IBM Cloud and the machine learning on a private cloud, but this is again an architectural choice. You could put both on IBM Cloud, or you put them both on private cloud. Okay, and the information can then, the response from the machine learning system can be pushed back to users, typically cooperative administrators who might get insights from those information. So the example would be pictures from the crops to see in what state is the crop, and based on the color, did they have enough moisture? And we can, for example, have experts who label those pictures, and the machine learning system can be an image recognition system which knows if the crop had enough or not enough moisture. So this is a way to share expertise, and so experts can push data to the system, and users can ask and send requests to understand if their crop is rightly moisturized. This is one example out of many ones. And again, we have those resources, technology resources. Here, there is a very interesting one. We'll be talking a little bit about it, about analyzing geospatial environment data. And we have also here an interesting tutorial in Node-RED, which is about creating a dashboard in Node-RED for early warning system for detecting earthquakes based on historical seismic data sets. And again, pointers to artificial intelligence resources, data science resources, IoT resources. Here, this is about API. So we have an API, how to build an API-based application. And again, NGO documents. Now let's dig on the clean water and sanitation sub-problem. So again, what is the problem? Let's get back here to the United Nations. Here, this is clean water is number 6 in this big 17 goals list. And for example, to understand how deep this problem is, you might want to know that 1 out of 3 people in the world do not have access to drinking safe and drinkable water. And 2 out of 5 people do not have basic hand washing facility. And 670 million people just do not have toilets. And you can imagine all the pollution problems and the health problems this can cause. And again, this is very amplified by COVID-19, so things are getting more and more urgent. Again, facts and figures here. Targets where you can get ideas, like, achieve universal and equitable access to safe and affordable drinking water. This is one of them. There are 6 of them expressed here. I'm not going to dig all of them. And so let's go back to the starter kit itself. The idea in these starter kits is to offer, to create an API to a system which allows users to access information on data collection, on water, and disseminate this information. So through this API, users will be able to push data and collect data and have information on where we have good water, when we have pollution problems, etc. So this is the idea of the architecture. The kernel of the architecture, well, at least from the front-end point of view, is a dashboard. This dashboard collects information through a universal API, which consolidates information, which is a unique API, which is homogeneous for many data sources like maps, water quality databases, water sources databases, and again, all those sources are available, some of the sources at least are available as data resources in the starter kit also. And here we have also put weather company data because, of course, weather reports are very important in this environment. And again, we can link that to recommendation engine, which would tell or highlight, for example, in the vicinity, what is the what places has healthiest drinkable water, and why, by analyzing this kind of data. This is one example of what we can do with this architecture. If we go down now to tutorial, we have this tutorial about building a dashboard using Geojson. Geojson is a format for geological geographic information in Node-RED, and I will dig into that. We have again this analyzing geospatial environment data. We'll say a few words about it. So now let's dig to this tutorial. Okay, this tutorial is about getting information, getting pollution information and displaying it. So to display it, you basically need to access geological data about the rivers, about where they are. You need to get information. So this is the source is the USGS, the United States Geological Survey, which hold those kind of information. To get information about pollution, so here we have chosen to address Aqua Ingenuity, which is an organization which provides information about pollution, and you can apply for this API. So you learn about that basically, and then it gives you prerequisites, how to install Node-RED on your machine or on a cloud. It tells you what is Node-RED, and by the way, Node-RED is an environment to do Node.js application in a visual way, and you create basically flows with nodes that have been either pre-built for you in libraries or that you can build by yourself. And the idea is to import palettes which have already some of those libraries for some nodes. So there is a dashboard palette that you want to import. There is a world map palette that you want to import, obviously to display the maps, and a table palette which allows you to display the pollution information. This is the 30-minute tutorial, and indeed I did it in 30 minutes. It's a reasonable time to do it. You learn about Geojson, and then after importing all those information and having subscribed to Aqua Ingenuity for getting pollution data, you basically import the flows from a GitHub, and you can import them in your newly created Node-RED environment, and observe the dashboards. So this is exactly what I did, and so I went to Wikipedia to understand more Geojson. Then I learned how to install Node-RED and how to add nodes to Node-RED. Then I went to this Node-RED palette, which is the dashboard, and installed it on my environment. I went to Aqua Ingenuity, which have a freemium version that you can subscribe to in order to get the data, the pollution data. I imported the world map palette. Then I imported the flow, and the flow is a Node-RED flow, which is written in JSON, and each here JSON sub snippet here is actually the node, and it gives you how it tells how each node is linked to each other. So you can import it in your Node-RED environment, and boom, this is what you obtain after that. And here you can see on the left the flow. And you can see that you can put here in this node, which is the Aqua Ingenuity node, which has been developed for the purpose of this application. You can see that you can put your username and password from Ingenuity. Here I have obfuscated them because they are, of course, secret. And now, yeah, there are two of them actually. If you look at the tutorial, there is the Ridgewood watershed flow and the Atlanta watershed flow. And as you import in the dashboard, then you can click on this button that is now available in your environment, and actually, yeah. Yeah. Click on this little button here to make this dashboard available. So the one that I mentioned is the Ridgewood Basin here. You have buttons here to visualize what rivers you are dealing with and what perimeter this is related to. So this consists, as mentioned before, as an interface on the left where you can enter zip code, submit, and here you have the map, and of course on the right you have pollution, and you see that this place is very polluted. And if you look at the dashboard from the Atlanta Basin, which is the second Node-RED flow that I mentioned before, here you have much more places, you have much more rivers that you can visualize. I'm going to visualize one or two of them. And on the right, you see that this place is much less polluted, and except for copper. And each time that you have a pollution level that is above a threshold, then it appears in red to highlight it. Okay, and there is another very similar dashboard tutorial, which is the Build Earthquake Early Warning. So let's open it. And it tells you how to build a dashboard, again in Node-RED. And so it's basically the same plan as before. And here you have another planet. In addition to the dashboard, the world map, and the table, you have a Twilo, which allows you to use Twilo to retrieve information necessary for this earthquake application. So it's another 30-minute tutorial, very interesting. If you look here in the dashboard, this is what it looks like once you have applied it. So you see the seismic graph on the right, and you see here location information on the left, and you can choose what time period you want to visualize, and you could use this information to do forecasting, for example, if you want to enhance this application. There is finally this last geospatial tutorial that I find interesting too. This is in another technology. This is using Jupyter notebooks with Python in order to retrieve data from satellite data from 40 years of moisture, soil moisture information from the European Commission. So on 40 years, you can see at the scale of the world how moisture has evolved concerning the soils. And so this is the first part of the tutorial: observe data and then use those data to do forecasting. And this is why this is Python, because this is a data science application using scikit-learn and using using SparkML to do forecasting. And you can see that you can visualize points on the planet that are critical, and you could basically forecast what's going to happen in the next 3-4 years if you build a forecasting model with data science libraries from SparkML, for example. And I think I will basically stop here. I thank you for your attention.
Thank you very much,
Georges-Henri, for this presentation.
Thank you
everyone for attending this presentation on starter kits, and I wish you all the best for your contest, your global challenge. Bye, thank you.
Bye. Bye.